Hi everyone, I'm Shreya Rutla. In this video, I'll walk you through my solution for analyzing the closest pair of points problem in Python using both brute force and divide and conquer algorithms. Let's get started. What is the closest pair problem? The closest pair problem asks, given a set of 2D points, which two points are nearest to each other? We'll solve this using different approaches and compare how they perform with increasing data sizes. Now, let's get started. Here is the configuration. The script begins with some configuration. We define the number of points to test, how much to increment them, how many trials to run for averaging, and the coordinate range for our points. Now let's go to the generate points function. This function creates a list of unique random 2D points. We store them as XY tuples and ensure they are unique using a Python set. Now you can see the brute force closest pair function. The brute force method checks every possible pair of points. For each one we compute the distance and track the closest. Its time complexity is O(n) square, so it's simple but slow for larger datasets. Now you can see the divide and conquer closest pair function. The optimized version uses divide and conquer. It splits the data into halves, recursively finds the closest pairs, then checks across the center strip to catch any pair that crosses the boundary. Now you can see the run trials function. Here we test each algorithm by running multiple trials on increasing input sizes. For each trial we time how long the algorithm takes. Results are printed and collected for plotting. Now, now you can see the save and display results function. Once all trials are complete, the results are saved as CSV files and graphs are generated using Matplotlib. These compare empirical timing with the theoretical time complexity. Now let us see the output. Here you can find the result here, which displays a summary of constants used and the full data set. This is easier to explore the outcome visually. You can find that each trial is run for this many seconds, like 0.844 seconds, and it displays the optimized average. You can find the predicted time for each trial here. Now you can find the CSV file for the theoretical values, empirical values, and the ratio and the predicted time analysis. These are the brute force results, and now we can see the optimized results here. And here are the graphs. This is for the algorithm performance comparison, and the figure 2 is for the brute force empirical versus predicted, and this is the figure 3 for empirical and this is the optimized algorithm, that is empirical versus predicted graph. These are the graphs. As expected, brute force becomes slower as points increase while the optimized algorithm scales better. Thank you for watching. This demonstration shows how we can use both simple algorithms to solve geometric problems efficiently. Thank you.